Alright, welcome to the video. In the previous video, I went over the derivatives of the 6 trig functions, and in this video, I'm going over the derivatives of the 6 inverse trig functions. So these are the derivatives, they're the most important for you to know, probably. The derivatives of cosine, cotangent, and cosecant I will go over as well, but these are generally more tested, and you'll see the derivatives are very similar. So, derivative of sine inverse is 1 over the square root of 1 minus x squared. The derivative of tangent inverse is 1 over 1 plus x squared. And derivative of secant inverse is 1 over absolute value x times square root x squared minus 1. So this one is kind of the weird one, secant inverse, because it has that absolute value. But if you work with them long enough, you'll generally become more familiar with them over time. Alright, so these are kind of like the evil twins of the other three. They're very, very similar, and you might get tripped up, like, which one is which? Which one has the negative, which one doesn't? So, basically, the ones with the co in it, so like cosecant, cotangent, cosine, all of those are the ones with the negative in it. Meanwhile, the ones without it, like sine, secant, tangent, those are the ones with the positive. So sine and cosine go together. So the derivative of cosine inverse is just minus that of the sine inverse. Similarly, derivative of cotangent inverse is just negative 1 over 1 plus x squared. So that's just the opposite of the tangent. And for cosecant inverse, it's negative 1 over absolute value of x times square root x squared minus 1. So for the ones with the co in the name, you just flip the sign. Plus, so our first problem is the derivative of sine inverse of x multiplied by cosine inverse of x. So we need to use the product rule here. So we can call this function on the left f, the function on the right g. The product rule tells us that this is going to be f prime multiplied by g plus f multiplied by g prime. Now, what is f prime? Well, that would be the derivative of sine inverse of x. So that would be 1 over square root of 1 minus x squared multiplied by g, which is cosine inverse of x, plus, all right, what is f? F is sine inverse of x. I'm going to write it on the right. I'm going to write g prime first. So the derivative of cosine inverse, that is negative 1 over square root of 1 minus x squared. And that is multiplied by f, which is sine inverse of x. So I'm going to factor out this 1 over square root of 1 minus x squared. So this becomes 1 over square root 1 minus x squared multiplied by cosine inverse of x minus sine inverse of x. That is our derivative. All right, the derivative of arcsecant of x squared. So if you'll notice, instead of having the secant inverse, we have arcsecant. But that just means the same thing. The prefix arc just tells you that it's the inverse. So we know that we're going to need a chain rule here because we have a function on the outside, which is arcsecant, a function on the inside, which is x squared. The chain rule tells us that this is going to be f prime evaluated at the inside function, which is g, and then the whole thing multiplied by the derivative of g. So what is f prime? Well, the derivative of arcsecant is, or derivative of secant inverse, either one, is 1 over the absolute value of x times square root of x squared minus 1. But here, instead of evaluating it at x, we're evaluating at x squared, because that's our g function. So this will become the absolute value of x squared times square root of x squared minus 1. And then that's multiplied by the derivative of g. So 2x, because the derivative of x squared by the power rule is 2x. So I'm going to make some simplifications. First of all, these absolute value brackets are unnecessary because x squared is always going to be positive, so there's no it's not going to change anything. So we have a 2x and we have an x squared, so one of these x's up top will cancel. Okay, so we'll be left with 2 over x square root. So we have x squared, whole thing squared. So we multiply the powers. So this becomes x to the 4th minus 1. So our final derivative is 2 over x times the square root of x to the 4th minus 1. Alright, so now for our final bit of practice. We have 3 problems here. Our first one is the derivative of the tangent inverse of e to the x. So we're going to need the chain rule. For all these problems we will actually. Our outside function is tangent inverse, so we can call that f. Our inside function is e to the x, we can call that g. So we know this is going to be f prime of x evaluated at g, and then the whole thing multiplied by g prime. I'm not going to write all that out. You should be familiar with that already. So what's the derivative of tangent inverse? We know that's 1 over 1 plus x squared. Now, instead of evaluating that at x, we're evaluating at x squared. e to the x. So 1 plus e to the x, whole thing squared. And then what's the derivative of e to the x? It's just e to the x. So this becomes e to the x over 1 plus e to the 2x, because you can just multiply this x and that too. So that is our derivative. The derivative of cosecant inverse of 7x minus 6. Well, our outside function is cosecant inverse. We can call that f. Our inside function is 7x minus 6. So this is going to be f prime of g multiplied by g prime. What is f prime? F prime is the derivative of cosecant inverse, which is 1 or negative 1 over absolute value x times the square root of x squared minus 1. But we're evaluating that at g. So absolute value of 7x minus 6 multiplied by the square root of 7x minus 6 whole thing squared minus 1. I'm not going to simplify that. You definitely can, and sometimes you probably should, but I'm not going to. That's more of an algebra problem than a calculus problem. And the derivative of g is just 7. So this becomes negative 7 over absolute value of 7x minus 6 multiplied by 7x minus 6 whole thing squared minus 1. And that is our final derivative. Alright, so one more problem. Derivative of sine inverse of square root of x. So I'm not going to write it out, but our outside function is sine inverse, and our inside function is square root of x. Derivative of sine inverse of x is 1 over square root of 1 minus x squared. But we're going to replace that x with square root of x. So square root of x squared. The square root and the squared will cancel. And then on the outside, we need to multiply it by the derivative of square root of x. So that's the derivative of x to the 1/2 power. That's my prime symbol for derivative. So we know that the power rule tells us the derivative of x to the n is equal to n times x to the n minus 1. So this is going to become the derivative of x to the 1/2. That's 1/2 x to the negative 1/2. Now the negative power means you can bring it down to the denominator. So 1 over x to the 1/2, which is 1 over square root of x. So that's 1 over 2 square root of x. So this becomes 1 over square root of 1 minus x multiplied by 1 over 2 square root of x. Now, because we have these square roots, we can combine the contents of the square roots into 1. So square root of x times 1 minus x. So our final derivative is 1 over 2 square root of x times 1 minus x. Alright, thank you for watching. I hope that you found the video helpful. In the next video, I'm going to be going over the derivatives of the hyperbolic trig functions. So check that out if you need help with that, though those are not usually very heavily tested, but I think it's still good to cover. Anyways, I hope that you enjoyed the video, and have a good rest of your day.